Welcome to solverfy.
So the chemical reaction is given here, and to determine the molarity of the calcium ions, it is necessary to use the solubility product constant. To do so, we need to first know what the initial concentration of the ionic species are. So to find moles of calcium, 2 plus, what we do is we have 9.7 times 10 to the negative fifth, and that's grams per milliliter, okay? And we have 104 milliliters of that. And we don't need to convert this to liters because this is in milliliters here. And so this will cancel out. But we do, in order to find the moles, we do need to have 1 mole here and divide it by the mass of the calcium. Okay, so that makes the grams cancel out there. And this equals 2.5 times 10 to the negative fourth moles. Okay, now we need to find the moles of the C2O4, 2 minus. And we have 100 milliliters. This one we do need to convert to liters. So we have 1 liter over 1,000 milliliters, and that will cancel those out. Okay. And we have 0.155 moles of this per liter. So that makes the liters cancel out. And this is for the sodium along with the C2O4. Okay, so what we need to do is we need to take that sodium out by just dividing the 1 mole over this mole of the sodium C2O4. Okay, so that's really just to show that we're getting rid of that sodium and we're just having this C2O4 left, okay? And that equals 0.0155 moles. So now what we need to do is we need to subtract the moles of C2O4 from the number of moles of calcium. So we take 0.0155 and we subtract it by 0.00025. So what we get is 0.01525 moles. Okay? We'll just keep that right there so we can see it. Now we need to calculate the total volume of the solution. So we have 100 plus 104 milliliters. And we multiply that by 1 liter over 1,000 milliliters, just to convert it to liters. And these will cancel out. We'll come up with the appropriate units, and it's 0.204 liters. Okay, so that's the total volume. Now we need to find the molarity. We have the moles, and we have the correct volume, so we need to find moles per liter. So what we do is we take 1.5 times 10 to the negative 2, which is this number up here, the number of moles, okay? I just put it into scientific notation. Moles, and then we divide it by 0.204 liters. And so that equals 7.4 times 10 to the negative 2 molar. Okay, so we have our concentration now. Next, what we need to do is we form an ice table. If you remember, the I stands for initial, the C stands for change, and E stands for equilibrium. We really only need, we have the equation, and we're going to look at the end of the equation, the product side of the equation. So we have calcium here, and we have the C2O4 here, and then we have H2O. So initial, that is, there's 0 of that, it's not applicable. There's 0 of this, and then we have 7.4 times 10 to the negative 2, which is that number we found there, okay? And all we do is we say plus S, and this is plus S as well, and we end up with S. Here we end up with 7.4 times 10 to the negative 2 plus S. Okay. Now we need to put this in our KSP expression, which equals the concentration of calcium, 2 plus, and the concentration of C2O4, 2 minus. So the KSP for this reaction is 2.3 times 10 to the negative 9, and that should be found in Appendix C. We don't know this number, but we do know this one. It's 7.4 times 10 to the negative 2. So we just move the calcium over, and we move this over as well, and that equals, we just divide it over, and that equals 3.1 times 10 to the negative 8 molar. So assuming that precipitation of the calcium C2O4 with the water on the reactant side, go up here. So assuming that the precipitation of this is minimal, and actually that should not be a plus, that should be a dot because the water is with it. Assuming that the precipitation of that is minimal, it is found that the concentration of calcium is 3.1 times 10 to the negative 8 molar.